In today's episode, we'll be coding a Wordle game. You guess a 5-letter English word and you try to get to the correct word by getting different colors to guide you to the correct answer. Let's get started. Okay, sup guys? Welcome to today's show. So today we're gonna create a Wordle game. And in order to create a game like that, we need to have a lot of words of 5 characters. So let's begin by going to Google and let's search for English words txt, and we scroll down to the this one, University of Michigan, and then we download this link right here. Copy link, and let's go in here and let's set the home directory to current working directory, and let's wget this file. So if we open this up in VI, we see that we have all these annoying Windows new lines. So let's use call to remove that. And then we have word list dot. Let's also sort and unique them. And then we have a word list dot txt. And we check the head. Seems okay. We check the ending. Right. And we open up in VI. And let's remove this empty line here. And what else do we do? Okay, guys. So now we have our wl.txt, and if we check how big it is, it's 69,000 lines. The next step is to only use the 5-letter words, right? So in order to do that, we need to do a little bit of regex magic, regular expressions. And since this is a beginner video, I will try to make the easiest regex possible. Alright, so we use the grep command and we add dash big E to use the extended regular expressions. And what do we put here? Well, first we begin the line. So think of the file. We begin the line inside of the file. And that was this caret thing means. And then we can have a dot. A dot means any character. And we want 5 characters, right? So the naive way would be to do just dot, 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 dot. 5 dots. And then we need the end of the line. So this ought to collect only the 5-letter words from this word list. Let's see if it does that. So WL 5-letter words. .txt. And we do a head of that new file. That seems okay. And we do a tail. And my understanding is that if the head and the tail looks right, then it has probably worked. But we can use the more command as well to be more certain. So you press space to go down one line. And a lot of these seems almost like random characters, but every single one of them is a legit English word. What did we have there? I saw a hole somewhere. This. CME. Why did we get that one? That's very odd. You know what we can do? It seems like only some of these words, like a very small amount, is not 5 letters. So let's, instead of digging into more regex magic, let's just add a function in our code that checks that the word is 5 characters. Otherwise, it will just skip that word. We can also do something like sort dash big R in this file. And we put it into wordlist.txt. We clean up the ones we won't use. So that's WTL, TXT, and the W file. So find one last check. We do the head of the word list. Sounds okay. Besides that head, perhaps we did match on words that are already less than 5. That's probably it. Never mind. So yeah, I might have a solution, but in my head, but I don't want to dig into that right now, because that can be pretty time consuming and advanced. So let's see. We will also check how many words we have. Alright, 5,000. That's probably so every user of this game will never see a duplicate, right? Okay, so let's see. Let's begin coding then. I have already prepared my VS Code directory right here, and I will create a new file which is called wordle.c, and I will not use an H file this time. I will only use one single file, and this is the wordle.c. And let's see, I think I can minus once, and I need to resize this window a little bit. Yeah, good enough. Okay, I hope you see this. So we have the wordle.txt, and let's include all the things I usually include. So we have standard IO, we have UniSTD, we also include stdlib, And finally we include string. And that's it for now anyway. Alright, so what do we need? Well, we need a function which is able to check if the character in question, so it checks one character. Let's say the word is apple, and the user provides the letter A. Then we want to highlight that this A is in the correct place. And maybe next time he supplies, he does supply another word. So what should we take? Canon. So C is not there. The A is there, but it's at the wrong place. So this will be yellow, right? And yeah. And then he might do something like, I'm trying to figure out a 5-letter word beginning in A. What about atoms? Then the A will be at the correct place. We have no T, we have no O, no M, no S. So that's how it's supposed to work. We will have one function which checks one character, and then we loop that for all the 5 and presents a result. But first, let's define a simple structure. So let's call this word, S-word. S is for struct, by the way. And a struct is a blueprint for an object or your own defined data structure. So you take several variables and you push them into one unit. And why do we need this? Well, first of all, we will need a string. So let's call this the actual word. And this doesn't have to be bigger. Let's do 8. It will be 8 anyway, because they can't be any smaller, right? Alright, so we have the word. What else is interesting about this word? Do we need some more instructions? So each word will be saved in memory, and we will also let's have a size. Let's just do, I will try to do as simple variables as I can, so no unsigned into 16 bits, etc. So let's have a size, but it will always be 5, right? I don't think we need this struct at this time. We might need one for the guess later on, but not currently. So instead, let's just create the main, by the way, so we will be able to compile this at some point, like so. And let's be vigilant with the function definitions, because that is a good practice. So as soon as you define a function, make sure to create the function definition as well. And basically, it's the first line of the function, but with a semicolon at the end instead of this bracket. And you put them all at the beginning of your code. Alright, let's just compile it. So we do GCC, and we don't need any we can have wall, by the way. W-all means that we get all the extra warnings and stuff. That can be good. And we have the Wordle.c, and we want the output to be Wordle. Okay, no problem there. Okay, so let's create this function that checks one single character. So we can begin by doing the signature of the function. So, and what should it return? It should return, that's what I was thinking about earlier. I will show you. I want this to return a result, right? And I'm going to show you what a result is, or what it will be. And let's call this function check char, perhaps, or maybe just cc check char. And what does this function need? It needs two characters, right? It needs the actual correct words character, the one we are comparing. So let's call this correct. And then we have the guess character. And that's basically it, I think. Perhaps we do need the, let's see, we need the index as well. So let's do int idx, that's short for index. And then we will need the actual word as well. So the word will be, let's see, the word will be a char pointer. I will try to avoid pointers, but in this case it's a string, so that's always denoted as a pointer when you call a function with it. Okay, so this is the word in question. We need that in order to figure out if the character is in the correct position. And let's do let's move this up to here. Make a little space, and let's see. Okay, let's create the function definition right away as well. So we have cc, and we send a char, and we don't give the name of the variable here, we just give the type. And we have another char, and then we have an int, and finally we have a char star, right? And we also need to define this result, and for that I think we do need a struct. So s result, and what do we want to return here? So let's see. We want to say one of three things, either if it's green, yellow, or red. So let's just call that color. And let's define the colors as standard definitions. So result green. Let's do that 0, and let's define result yellow as 1. Let's start by 1, by the way. Then we can have this as 2. And then we have red, and let's do 4 for that. And why 4 instead of 3? That has to do with flags and stuff, and I don't want to get into that in a beginner video. I have good other videos about that exactly. Okay, so we send back the color, and do we need to tell the main program something else? Yes, we need to tell the main program what index the different results are connected to. Maybe we should return 5 results. Or at least 5 colors. Like so. And yeah, let's do it like this. And then we use typedef just to make it give it a suitable name. So what we want to change is the struct as result, and we want to call it result with a big R. And that is what we are returning here. Okay, I think this will work. So at this point, we're only going to return 1 result. Are we overcomplicating this? Let's just do this instead. type of struct, instead of doing this as a struct, I still want the result, but let's just make this a char, because then we can use these definitions against this char instead. So that means that in this case we return one result, but in another case perhaps we will return several results. So we can even annotate that by doing type def result 5, because we only ever gonna need either one result or 5 results. So let's call this results with an S at the end. I think you can do this. Okay, enough of that. Let's begin creating our function. So basically we will have a single switch statement here, and what we want to check is the word, but we want to check the IDX position. So if that is 0, we will check the first character in the word. And what different possibilities can we have? We can have the same. So we can have a case for correct. I don't think we need to have this guess parameter, by the way. So this is quite usual when you code. You optimize it step by step when you figure some other better solution out. So let's remove one of the chars here as well. So okay, so if we pick the correct one, and then we will return. I wonder if you in the last C version just can do something like right, it's not a struct, never mind. So we will simply return one of our constant definitions, and that'll be result green, because if we pick the correct letter at the correct place, then we can just return that. What else do we have? We have a, let's see, we can have a default where we check with an if statement if the let's create a function called isIn, and we do correct. So if the correct if the guess Yeah, okay. Instead of correct, I think it will be better to have the guess back. So let's define our correct. What just happened? Let's define our correct right here instead as a regular local variable. So the correct character for that position will be the word at that index, right? Okay. So if the let's see, if the correct character is inside of the word, but since we are at the default branch, it will not be at the correct place. But if it's inside the word, then we can also early terminate. We can return result yellow for that position. And in all other cases, we can denote that by just going outside of this. Since we return in both possible cases, we can just return the other thing right here. So that will be a return, and let's see, red, like so. And okay, then we have a CC function, you guys. Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support. Okay, welcome back everyone. Let's continue with our Wordle game. So this far we have written a function which will take one single character from the guess and compare it to the different possible results. So it can be either green, yellow, or red. Now we want to write a function which takes the entire words and calls this function 5 times. So let's begin by defining the signature. This one will return results. So that is 5 units of the result type. And the last function was called CC for check char. Let's do this CW for check word. And what do we need here? We need, let's see, let me just check something. Correct equals word at index switch. I think we might have made a mistake here. What we want to compare is the guess. So the guess should be checked against it if it's correct. Let's see if the word is the correct. And in here we ought to do the same, right? So we should check the guess against the word. Alright, that's better. Alright, so let's see what we need here. We need the entire guess word, and we need the entire correct word. So let's name it the same, but this time we'll put a star in front of them. So we take the guess, and we take the word. Like so. Let's give us a little bit of space to work. And we need some kind of result variable. So let's do results res. And we need an integer as an index to go through all of these characters. And let's see, that should probably be enough. Let's try it. Alright, so we start index from 0. At each iteration we want to check if I is less than 5, and then we increase I. And what do we want to do at each iteration? Well, we want to set the res I, so the current character that we are investigating, and we set it equal to our cc function. And what did it take? Okay, now we made the whole thing up here. Let's move it later. Okay, so we have a guess index word, and that is the correct word. So the guess will be guess I, because it's a character that we are investigating from the guess. And then we have the index, which is simply I. And we have the word as the correct word, right? Yeah. So when we create those kind of helper functions like cc, it makes it very easy to write functions like this. So let's simply return res, and we're done. And let's see, let's move this whole thing. Let's put it here. And then we create the signature. That was our intention from the beginning as well. So results and C word, we called it. And it only takes 2 char pointers, or 2 strings rather, like so. And now we have coded a couple of functions, so I think it's time to test our code. a little bit. And in order to test the code, I want to create one more helper function. Let's call this, let's see, let's call this print, or let's add the prefix example so we can easily find it when we want to remove it, because this should not be in the finished product. This is only for us now. Okay, so the example, what does it do? It takes a let's see, we need a name for it first. So example print results, and it takes a results variable like so. And let's move this up here, but let's also put it here, and then we give this a name, res, and what do we do? Well, we have the results. We just need to go through the results and print it somehow, and we are going to print it more good looking later on, but at the moment let's just do some kind of naive implementation of this. So let's loop through the results. We set I equal to 0, I less than 5, I plus plus, and at each iteration, what do? Well, we do a switch of the results at that position. Right. And there are 3 different possibilities. So, case, we can have a result green. And in that case, we, let's see, we just print something like green. Let's make it easy. And we break. You always need to end a case statement with break or return, unless you want it to continue. And then we have the result yellow. Let's copy this line, paste it here, and type in yellow. And finally, well, let's break first. Finally, we have case result red. We'll do the same here. Break. And then we probably don't need a default statement, but you never know. Something can go horribly wrong sometimes. So in that case, we can print unknown, and then we print the integer value of res I. and at the statement at the end, you don't need break, but I usually put it there anyway, just out of habit, so I don't forget it some other time. Alright, and this is all this function needs to do. And we don't need this return statement, it's a void function, but I usually put it there as well. I like to have structure. Alright, so let's try this out. So let's see. Let's begin, by the way, by altering the signature of main a little bit, like this. And in here we put the argc and the char argv. We check if argc is less than 3. That means we did not supply 2 arguments. And then we print the standard error. That's just the default thing that you ought to do when you work with a command line arguments. So you print the usage, how it's supposed to be used. And it's usually done like this. Let's do this. Correct word, guess word. And then we give arg 0, which is our binary executable file, and then we return -1. So if we don't have the correct argument, this is printed and we quit. If we do have the correct argument, let's create 2 pointers, and I'm trying to avoid pointers, but in this case it's a very easy kind of pointers, and it will improve the readability of the code. So let's create one for the correct, let's just call it correct. It is the correct word. And then one for the guess. Set the correct equal to the first command line argument. We set the guess equal to the second. And we also need one results variable. Then we set result equal to our check word function, and it takes the correct word and it takes the guess word and returns results. And then we can give this result to our example print results res. So this should work, I think. There's probably some small bugs here and there, but the compiler will help us find those. Alright, so let's see what it says. We run the same GCC command as before, and we get a couple of errors. Let's see. Okay, it doesn't seem that typedef has a support for that kind of structures after all. Typedef result 5 results. What if we were to do typedef struct s result? I think we named it something like that. Or do we have it? Right, it's not a struct. It's a char. So this should be a char 5. That ought to be possible, right? Let's see. And we space down a little bit and do clear. And that's so it's easily found first or the last invocation of the command. And we go up and no. Expected identifier or parentheses before that token. Before that token. Never mind. Let's not go too deep into this. Let's remove this and just replace it with results like this. That should work, right? I think we can do it in the whole file. I'm not sure if you have the Vim motions installed, but in case you do, if you zoom in a little bit here, you can issue the command %s and then a comma, and we want to change results to result like this. And we want to do it globally, but we want to confirm each and every one of them. Right? Example print result, yes. Results, CV, there and there and there. Alright, let's see what it says. Probably we need to, in some of these cases, by the way, let's go back here and we do result, one of these. Result bracket. So void example, this is right, I think, because it's a signature of a function. In this case, it should be the same. And there as well. But when we define variables, we probably need to put the 5 there. And same here. And that's it. Alright, let's see what the compiler says. Okay, expected identifier. It gives the same error, but result. Okay, let's do it the good old-fashioned way with pointers. It's very tough to totally don't use pointers. So let's do this a result star instead. So we search for result in the bracket. Same here, it's a result star. Result star. Here as well. And here, yeah, here as well. No, wait. Since we're defining a local variable result, right, in this case we need to do this. So that's my mistake. Like so. And I think we got them all, right? Like those Tamagotchi thingies. Okay. Case correct. Case label does not reduce to an integer constant. Interesting. Case correct. And what is correct actually? What line was that? 45. Correct is a char. Case correct. So it's not able to. Okay. Yeah, it's in the runtime. Yeah, let's totally scratch this case statement. And let's do, this will be an else if, and let's do an if statement instead. So if the guess, let's see, if the guess, and then is it char, is equal to the word at, or the correct character of the word. In that case, we return result green. If not, if this is in this one, then we return yellow, otherwise we return red. And we never created this is in function, by the way. So let's do that too. And this should be a boolean, either true or false. If this guess character is somewhere in this word, it should return true. So let's make this a bool is in, and what order did we put the arguments? The character is first and then the word. Perhaps we should also give it a no, let's do another way. Alright, so we have a char C, and we have a string str, and let's create a result. Let's call it, let's make it a bool. Let's call it ret for the return value, and it's false from the start. And we also need an int I, and an int size. We set the size equal to the string length of str, and that should always be 5, right? But we might reuse this function somewhere else. So let's do it in this kind of way. Then we loop I equal to 0, and we loop as long as I is less than size, I plus plus, and at each iteration we only do one if statement. If the word, no, the str at this position is equal to the C. If so, we do two things. We set the ret equal to true, and we break. That's all, because it's false from the beginning, so we don't have to worry about that. And then we simply just return the ret. Right, I think this should work. And let's do a signature for this as well. We have char, no, we have bool is in, and we have a character, and we have string, like so. And also we need to include the booleans in let's std bool.h, like so. Alright, let's see what it says. Okay, we're getting closer. Return res, warning, function returns address of local variable, okay, 77. Let's see what it's about. So we return the res here, and the res is an array, right? I think it ought to be enough to make this static, so we save it in a place where the other functions will be able to reach it. Okay, that's one. What is this other one? Return -1, that is just a typo. 87, missed a semicolon. And what else? Res equals to assignment to expression with array type, right? All this stuff is because we changed the variable type from well, to pointers and stuff. 93, so we need to clean up a lot of different things. Okay, so res equal to blah blah blah. I think it should be enough just to make this a pointer to res. So we clear and we run GCC and it compiles without trouble. Alright, let's see if it works now. So let's see. Okay, we forgot a new line. And then it won't fit. Let's do this. Alright. So when we run this, and this is just the example because we will create a game out of this. But we supply it with the correct word and the player's guessed word. So let's see. We give it a 5-letter word. And what did we have before? Let's see. Let's do canon. And we need a guess word with some of these characters inside, at least, I think. So let's do nylon, the fabric. Okay, so the N turned red, or how should we read this? Let's see. It's a little bit weird because the N, okay, maybe from the reverse order, because the N turns green because it's, no, it's not at the correct place. What about the Y? Maybe we gave it the wrong order because the Y, red, L, we do get different colors, but I'm not sure what it's based upon. I think we need to look over the code once more. And let's see, if we begin with this, the smaller function, CW. So we define a result and we set the first of this result equal to whatever CC does, and we send the first letter of the guess. Seems right. We send the index I, that should be 0, and we send the word. And what did we give it? The word. Guess word. Word guess. Okay, we mixed those up. I hope that's the only error. Because the first thing should be the guess. Let's see. By the way, let's undo this stuff. So we send the correct word, then we send the guess, and this takes the guess and then the correct word. Okay, so let's change it here instead. Okay, let's try it again. I think there's something else that's wrong, by the way, but let's take that when it happens. So let's do this again. Canon and nylon. Okay, so the N we got yellow because the N exists here but not at the correct place. The Y is red because it's not here at all. The L is also red, not here. The O is green because we have O, and the N is green because we have N. It works. The most difficult part of the game is done. Now we only need to do the infrastructure around. So basically we need to read all these words from our list or text file, and we need to randomize the order somehow, and well, then we just need to present it to the player, and in a nice kind of way show the results, not like this, but with actual colors, and I want to do something like, if in this case if we base it on this guess, the N should be yellow and the Y should be red, L should be red, and ON should be green. And at the next line we should do something like this. So yellow, red, red, these are still unknown, and then we have ON already done, and then the user can guess again based on that. Okay. So that is the next thing we're gonna do. Okay, welcome back. Let's finish this game, shall we? The only thing that's left is reading from the file, getting all of these words, and randomize a word each time we pick, and then write the input-output kind of stuff. So reading from standard input the answer and printing the result. Okay, so where should we begin? Let's start by reading the entire contents of the file into a two-dimensional array. I think it will be the easiest way of accomplishing what we want, because we have, let's see, word list. We have 5,195 different words. So let's see. Which is the best way. Yeah, well. Let's write the function. Let's call it, we don't know what it's going to return yet, so let's just do int for the time being, and we will call this read file, and we will supply it with a file, and also a number of items. So let's call this max. And let's make some room. We are going to need a buffer, and it doesn't have to be that big since all the words are very small. Let's make 8 characters, and let's see, we also need some kind of I as a counter, and we need a file descriptor, and let's make it easy for ourselves by using the fopen kind of syntax. So let's open the file first, and let's see later what we need to add. So we fopen the file name with read permission, and put the fd like this, and if not fd, then something is terribly wrong. So let's do something like p error fopen, and let's return for the moment -1. Alright, so that's this. I'm still considering what kind of data structure we're gonna use. Since we know all of the words is going to be 5 characters, I think the most optimized way would be to use dynamic memory. It's something that I actually wanted not to do because it might seem a little bit advanced. But if you don't really understand this part, I have a very good video on dynamic memory and malloc that you should check out. So let's see what we need. We need a char, and it'll be a double star because it will contain different strings. So it's an array of strings. And let's call this ret because this is what we want to return, right? Yes. So char double star this, and then we can't really return -1 like that. Instead it'll be char double star 0. Yeah. Okay, if we are able to open the file, then we want to allocate the memory. So let's calculate the size first. Let's see. I wonder if it's possible to define it like this. We can try that. So ret should, no, we need to calculate the size first. So let's create a variable for that. It can be a regular int, size, and the size is going to be the maximum number, and we need 5 bytes per variable. Yeah. So then we can malloc. We set ret equal to the char double star version of malloc. We allocate the size. If ret doesn't return something good, we fclose our fd, and we p-error. P-error is print error, by the way, so it prints the thing we specify right here together with the actual error messages from the last run function. And then we returned char double star 0. Alright, so at this point we do have our data structure. We need one more variable, I think. Now we can reuse the size variable. This is mutable C. Anyway. Alright, so we will read from the file into our buff, and the maximum size we're going to read is 7 bytes. I usually take this value -1. And where we're going to read it from? We're going to read it from fd. And then we're going to loop as long as this is true. So it's as long as it is able to read anything. I also want to zero out the buff. So we put zeros, 8 of them. So it's empty and nice before we read into it. Okay, so now we can set size equal to the string length of the buffer, so the word that we have read. And let's see if we read the word canon. Or let's do nylon. We are also reading the new line, and we have this invisible 0 after. So we want to remove this new line. size should in this case be equal to 6. So 1, 2, 3, 4, 5, 6 for this new line. And the indices will be 0, 1, 2, 3, 4, 5. So the 5th index, that is the new line, and that is what we want to get at, because we want to remove it. So string length returned 6, and we want to get at 5, so we take 6 minus 1. We can actually just make size 5 bytes instead. And then we take buff and we index into this 5 and we set it to 0. And at this point, let's see, before we do that, in case string length would return 0, then we're in trouble, because then we'll try to index into -1 and set it 0. So we need to check for that. So if size is less than 1, then we just continue. But by the way, before we continue, we need to clean out the buffer as well. Like that. Alright, so now we are protected. And now we have basically we take this new line and we create another of these 0 bytes. And this doesn't really count. So next check we want to do is if the size at this point, because it should be 5 if we have a 5-letter word, if size is not 5, then we will do the same as above. We will just skip this one. So we 0 out our buffer and we continue to the next iteration. But at this point everything is alright. We have the correct 5-letter word. Now we just need to copy it to our structure. And we could just let's see. We could just use string copy, but since we are only calculating 5 bytes for each of them in order to save some memory, we could do 6 and then we could just string copy the contents. But at this point it will be easier, although I think the easiest way is just to do this manually. There's only 5 anyway. So we have the return value at our current index. Let's set I to 0, by the way. We call it I, right? Yes. So this is the number of the word we're at. And this this word has 5 characters. So 5p, and it has number 0, 1, 2, 3, and 4. And we should just be able to set it to the corresponding buff. This is not the most beautiful code, but I think it's the right thing to do in this case. We could make a loop or something, but I don't mind. Alright. Is there something weird going on with the indentations, by the way? They're inside this loop. No, it's just big. Everything is just big. What to do at the end? We want to memset our buff at 0.8. We want to increase our n. We do also want to check that that thing we ought to do in the beginning instead. So at the beginning of this, no, end is good. After we have increased this, we check that n is less than max. Let's do like this. Let's check that max is less than n. So max should be more than n. Max should be more than n. But if it's not, if max is less than or equal to n, we break. Alright? And when we are done with all of this, we can simply fclose, fd. Think it would be interesting to return how many actual words we managed to get, because some of them is not the correct size, right? So I think it needs to know that. Let's create a structure for that. Let's call it, so what is it we are returning? We are returning words. Yeah, let's call it words. And what are we gonna return right here? We're gonna have a char double star pointer, which points at the array. Let's call it array, or just R. And we're gonna have a return value of type int n. No, incorrect. No, N is good. Alright, and we type def this struct as words into words. Like so. So what is this gonna return? It's gonna return words. And oh no, I'm at the wrong place. Wrong function even. Where did we put this? Right here, okay. So instead of char double star, we're gonna do words, read file, and ret, let's keep it like this, and let's create a words, and what shall we call this? Words. So, well, that complicates our error cases. That's a little bit annoying. Well, let's do like if the pointer inside of the structure is 0, then we are returning an error. That's a good enough solution, I think. So in this case, what do? We set words equal to, and can we initialize it like this? So we set the what did we call it? R equal to char double star 0, and we'll also set the n equal to 0. I think this is how it's done in the newer versions of C. And then we can just return this structure as a value. Something like that. And we need to do basically the same right here. So let's copy this. Should be afterwards. And let's do like this. Move this return. Let's jump this in a little bit. So we have close, we print error, words, blah blah blah, return words. And let's copy this again. Continue. And then, no. Oh, I lost my copy. Never mind, let's write this from scratch. It's a little bit different anyway. So we fclose, we set words equal to a structure where we have a pointer called R. It should be equal to our ret, and our n should be equal to I, right? Yeah. And then we return words. And I have no idea if this actually is gonna work. I haven't used this kind of solution before, but it'll be interesting to see. So let's run GCC, and we get a few errors. Expected expression before. It doesn't like our initialization. Perhaps that's because we used the wrong version. If we add standard equals C2X, no, still nothing. Probably we need to do that on the same line as we define the variable. I am not very fond of doing that. I think it goes against the C language somehow. But in need we do. So words equals, and words equals, and words equals. Okay, a lot of the errors and warnings disappeared, but not all. Let's see, red equals char, malloc size, assignment to expression with array type. Okay, it doesn't really like that thing. I was kind of hoping that it would understand what I meant when I did this. No, when I did this. Okay. What if? Because the problem is, I think we could probably have done something like this, but that's not really helping because we need the 5 on the other side, and I doubt that this will work. Well, we could try. No, of course not. Alright, we need to do it the good old-fashioned way now. So, char double star ret, and we'll let's see, will this stuff still work? That is the question. It has no real idea how big this should be. what if we were to... Well, we know how big the file is, right? We could make this some kind of dynamic array. That is also a new feature that I haven't really experimented a lot with. But we could just define it as, if we know the max, maybe we can even do it like this. Max 5. And we don't make it a pointer. And we make it static so we can return it. Well, it could work. And since this down here is a pointer, we should also be able to do this, right? Let's see. We probably need to change some other stuff, but let's see what it says. And perhaps we need to specify a standard. So C2x, no, C2x. Storage size of ret isn't constant. No, it isn't, but does it really need to be? With all those what is it called? Varying length arrays and stuff. Well, let's make it easier for ourselves. Let's remove this. And let's keep this as is. But let's go to the beginning of the file. And let's define max as a constant of 91 of 5. That's the correct one, right? Let's see. Word list there. 5195. 5195. I don't see why this shouldn't work. But we had some other error somewhere. Boof. Right, we should not malloc it. If we're at it's a malloc stuff. We forgot to remove that. Since we are putting this on the BSS segment now, we should not allocate heap memory space. So all of this malloc stuff can be removed. Okay, almost there. N undeclared. said, yeah, it should be I, not N. It should be I. And I. N equals I. Alright. And now we have one warning left. Initialization of char double star from incompatible pointer type char star 5. Are they really, though, incompatible? I don't think so. But, okay. Let's see if it's enough with A. R equals char double star. And we need the address of that thing. And we are compiled, ladies and gentlemen. So the next step is testing if this function really works. But this is a good place to stop for today, because we're already 2 hours into this episode. So next week we will finish this game. And if you like what you've seen this far, please like and subscribe. And thanks for watching, and thanks for today.